Welcome to this introduction to process-focused chromatography with Chromperfect. In many laboratories, chromatography begins with an instrument, a sample, and a result. In a process environment, the situation can be far more complex. A chromatograph may need to analyze several sample streams, operate continuously, respond to plant conditions, trigger alarms, communicate with a PLC or SCADA system, and return results in a form that can be used by the wider process. Chromperfect includes a number of specialized modules designed to connect chromatography with these process-focused workflows. The main areas are Chromperfect Process Control, the Modbus Repository, the Analog Output module, and, in some installations, OPC-based communication. These modules perform different jobs, but they share a common purpose: making chromatographic information useful beyond the chromatography workstation. Chromperfect Process Control, often shortened to CPPC, is the central automation layer for process-analyser applications. CPPC operates above the normal Chromperfect acquisition client. It does not replace the acquisition system. Instead, it coordinates the activities that surround the chromatographic analysis. A typical application may involve several plant sample streams connected to one chromatograph through a valve system. CPPC can select the required stream, allow the sample loop to fill, download the appropriate Chromperfect method file, wait for the instrument to become ready, and then begin the run. Once the run is complete, Chromperfect processes the data in the normal way. CPPC can then continue with the next injection or move to another scheduled stream. Different scheduling modes are available. A stream may run continuously, at fixed times of day, at specified intervals, in response to a priority request, or as a slave to another analyzer or stream. This allows one system to support routine process samples, calibration standards, validation samples, and zero gas or blank injections within a controlled sequence. The process does not have to be limited to one injection. A sampling cycle can include one or more blank runs before the sample, several replicate sample injections, and additional blank runs afterward. Each stream can use its own method files and data directories, allowing the analysis and reporting requirements to be matched to the sample type. CPPC can also interact with external input and output hardware. Digital outputs may operate stream selection valves, blocking valves, heaters, coolers, and other devices. Digital inputs may indicate maintenance mode, request a priority stream, or report an external alarm condition. Timed events in the Chromperfect method file can also operate relay outputs during a run. This allows valve movements or other process actions to be coordinated with the chromatography itself. Temperature sensing and control can also form part of the system. CPPC can read a main temperature sensor and, where configured, a backup sensor. Temperature readings can be recorded inside the Chromperfect raw file as user fields, creating a direct record of the conditions associated with the analysis. The system can also operate heating or cooling outputs according to configured thresholds. External alarms, temperature alarms, instrument status, calibration activity, and the currently active stream can all be displayed and, where required, passed to another control system. This is one of the main differences between ordinary laboratory chromatography and process chromatography. The chromatogram is not the only information that matters. The plant may also need to know which stream was analyzed, whether the analyzer was healthy, whether a calibration or validation was taking place, and whether any external condition could have affected the result. Chromperfect can store much of this information directly in the raw file. Examples include the run number, scheduling mode, stream type, calibration level, injection description, temperature reading, alarm state, and values from configured analog inputs. This creates a more complete analytical record and allows process information to be included in calculations and reports. Once the chromatographic result has been calculated, it often needs to be shared with a PLC, DCS, SCADA system, or another external device. One option is the Chromperfect Modbus Repository. In many industrial systems, the PLC operates as a Modbus master. Chromperfect modules may also operate as Modbus masters when communicating with field devices. Two Modbus masters cannot communicate directly with one another. The Modbus repository solves this problem by acting as an intermediate Modbus slave. Chromperfect can write results and status information into the repository. A plant PLC can read those values and can also write data back into configured registers. This makes the repository bidirectional for data exchange. However, the repository itself does not start instruments, select method files, or issue control commands. It is a Modbus slave and takes no action on its own. Where a value written through Modbus is intended to trigger an action, another Chromperfect module must be configured to interpret that value. For example, CPPC can monitor a designated holding register and use a written stream number to enable a configured priority stream. In that situation, Modbus carries the value while CPPC performs the action. The repository can operate using Modbus TCP IP or Modbus RTU over RS-485. It can store up to 2,000 holding registers, with each register given an address, a descriptive name, and a defined data type. Values can be represented as integers, fixed point numbers, Boolean states, larger integers, or floating point values using adjacent registers. This makes it possible to publish far more than a single concentration result. The repository may contain component amounts, alarm states, active stream numbers, instrument status, run status, calculated values, or information generated by external processing programs. Chromperfect also includes supporting tools that can transfer data from text or CSV files into the repository, perform calculations on repository values, or publish acquisition status received from the Chromperfect Acquisition Service. A heartbeat can also be implemented so that the PLC can confirm that the chromatography acquisition process is still operating. For installations that use conventional process signals, the Chromperfect Analog Output module provides another route. This module does not control chromatographic acquisition. Instead, it waits for a run to finish and for the Chromperfect data to be processed. When the resulting bound file appears, the module can extract the calculated amount of a named component and send that result to an Acromag analog output. A component concentration can therefore be converted into a standard process signal, such as 4 to 20 milliamps. Digital outputs can also be used to report whether a component has moved outside the high or low limits defined in the Chromperfect calibration file. The same module can read analog or digital inputs. These values can be written into the raw file as user fields before processing, allowing external measurements such as temperature, pressure, flow, or contact closure states to become part of the analytical record. This is an important distinction. The analog output module does not transmit the live detector signal. It transmits a completed and processed chromatographic result. The value has already been integrated, identified, calibrated, and calculated by Chromperfect before it is sent to the external process system. OPC-based integration has also been used in Chromperfect process applications. The OPC client module follows a similar post-run approach. It can read an input value from an OPC server and store it in the raw file. It can send calculated component amounts, alarm states, and other reportable values to an OPC server. This can provide a route into an existing DCS or SCADA environment where OPC is already part of the plant architecture. The exact combination of modules depends on the application. A system that must automatically analyze multiple process streams may require CPPC. A plant that needs chromatography results in Modbus holding registers may use the Modbus Repository. A site that requires conventional current loop or digital signals may use the analog output module. An installation built around OPC may use the OPC client module where supported and appropriate. These products are not interchangeable. They solve different parts of the process integration problem. CPPC controls and coordinates the analyzer workflow. The Modbus Repository stores and exchanges data with plant systems. The analog output module converts completed chromatographic results into physical, analog, or digital signals. OPC provides another software-based communication route into compatible control systems. Together, these capabilities allow Chromperfect to operate as more than a laboratory data system. They allow chromatography to become part of a wider process monitoring and control environment while preserving the analytical methods, calibration, processing, reporting, and data records used by the laboratory. For more information about Chromperfect process control and integration options, visit chromeperfect.com or contact the Chromperfect team to discuss the requirements of your application. Thank you for watching.